Okay, so we're going to start on this new subject called Flume. Okay, so what we are going to do in this subject is essentially talk about Flume. Okay, so what is Flume? Right, that's the first question you'll ask. Does anybody have an idea of what Flume is? Does anybody have an idea about what Flume is?
No.
Okay. So let me give you a use case, and let's see if you can answer that use case or give me a solution for that use case. The use case is that you have an enterprise service bus or a web server or a third-party application which is producing some data, and you want to capture that data real time and store it in HDFS, or capture that data, perform some manipulations on top of it, and then store it in HDFS. How would you do that? How would you do that? So the requirement at hand is real time. The requirement at hand is you need a pipe to take data through. The requirement at hand is I might be performing some light transformations on the data. How would you do this?
We can use Flume.
Huh?
We can use Flume to stream data.
Okay.
And
you answered it. So Flume is basically an event processing framework which allows you to actually, with the help of coding, allows you to take the data, perform some light transformation. I'm using the word light transformation here, and all that, right? So Flume is that. So Flume is a collection, aggregation of streaming event data. What is an event? Event is anything you want it to be. Event may be a file. Event may be a single attribute. Event may be an image. Event may be a record from the database. Event may be a JSON. Event may be an XML. Event may be anything you want it to be. So it basically, what Flume does is, it's basically an event processing framework which allows you to take those events and land them into the target store, which is HDFS, HBase, or basically it can land it to anything. That's basically what it is. Now, in a very trivial fashion, it's mostly used for log data. So you have the logs being generated. You use this framework for the log data and land it into HDFS, right? So what is the advantage of this solution vis-a-vis other solutions, which are more ad hoc solutions, right? It is reliable, meaning if an event is introduced into the framework, into this Flume event processing framework, it's guaranteed not to be lost. Number two, it is scalable. By adding more number of processing agents, basically you call them as agents, Flume agents. By adding more number of Flume agents, you can have scalability as far as processing is concerned. So you can process more if you add more agents. They're manageable, they're customizable, and high performance. Okay. Now, once I introduce the concept of an event, Then events have to be routed, they have to be processed, they have to be transformed, yada, yada, yada. So then we will start talking about declarative configuration. So by way of configuration files, I can dynamically configure an event to flow in a certain manner depending on some conditions of that event. Okay? So there is this contextual routing through dynamic configuration which can achieve this. Okay? It is feature rich and it is fully extensible. So you can extend this framework to suit your needs. So that is what Flume is. Okay? Any questions? So Flume is a, for lack of better words, it's a data moving, data movement framework. So what Flume lets you do is to move data from point A to point B. While you're moving the data, it lets you transform the data. So in that sense, it is more like an ETL tool. But in other sense, it is like other tools, okay? 4 concepts. So the very first concept which I would like to introduce for Flume is the concept of an event. What is an event? An event is the fundamental unit of data transported by Flume from its point of origination to its final destination. Event is a byte array payload accompanied by optional headers. So that last statement is a very important statement. Event is a byte array payload accompanied by optional headers. Now, you guys have gone through HBase, and what you must have, what you have quickly realized is once you start having something stored at that grain or is stored in that format, which is a byte array, you can practically represent anything or pass along anything you need to. Is that correct? So you can pass textual data, you can pass binary data, you can pass anything you want because it's a byte array, right? That's what that is where Flume derives its flexibility. That events can be anything. Events are essentially anything you want them to be. Okay? The only thing is that every payload which passes through the Flume framework is accompanied by the associated header information.
Okay.
First of all, if you look at Flume in isolation, it's like you was mentioning, it's a message event processing framework, and it could actually sync the data into either HDFS, HBase, or any other destination. So what makes Flume the preferred candidate that it is part of the Hadoop ecosystem versus any other messaging framework? What is that the Flume has the benefit of using in the context of Hadoop or in the context of HDFS or HBase? Why not other messaging frameworks if they're doing the same functionality? Hello?
Yeah, we are able to hear you. So it looks like
I think
either is
we lost the call.
He's on mute.
Yeah, I don't know why I went on mute. It happened in my previous meeting also. So You've heard my thing up until now, right? So what part did you miss?
I didn't miss any. I was thinking, Flume to me appears that a standalone messaging or event processing framework. So what I was thinking is, my question was, what makes Flume the preferred candidate to be used versus any other similar framework? Is there anything that is benefit of using Flume that is tightly coupled with HBase or HDFS? Why Flume?
Why Flume is because of the following reasons. Number one, it's open source, so therefore it is free. Number two, it is in some interpretations or in some sense it behaves like an ETL tool, which is it transforms the events or data as they flow through it, but not at the cost of being batch. So it's not batch, it is more real time. It sometimes behaves as a messaging framework, but without having any high memory footprints with application servers involved and queues and all of those things. So there is no concept of queues, etc. over here. There is a concept of queue, but it's called a channel. Essentially, it's called a channel. So in some senses, it behaves as a messaging framework, right? Now, a messaging framework, a JMS-based messaging framework, or a MQ framework, it does not transform the data. All it does is act as a framework to move data from point A to point B. In certain places, it also behaves more like a enterprise service bus. It has these salient features of a service bus, which is it takes the events based on the contextual information provided for that event. Contextual means the address where it needs to be delivered, what kind of transformations can or should be performed while this is being delivered, etc. It behaves as a service bus, but without the cost of having to do with XML. You don't have to do XML. It has a lot of plug-and-play sort of an architecture where you can plug in components at different stages of processing, be it at the time of ingesting of information or at the persisting of information or at different stages of transformations via channels. So it allows you to do that. So it is part ETL, it's part messaging, it's part service bus, right? So it's a unique marriage of a lot of different concepts. Now you know that through a service bus you cannot do ETL. You cannot, because payload is a problem. How you move data through that engine is a problem. This guy doesn't suffer from those problems, right? So Flume has natural advantages in that sense over other guys. But yes, it is definitely not a replacement for any one of these guys. It doesn't have very elaborate monitoring capabilities. It doesn't have XML payload transformations, XSLT transformation, that kind of thing. So it doesn't behave like a service bus. From a messaging perspective, I think it's got everything. It's got reliable delivery. It's got all of those things. If the messaging thing goes down, it does have failover capabilities and all that. Okay?
Okay.
Did I answer your question or no?
Yes. Does it also have any built-in classes or anything that naturally integrate with HDFS and HBase?
Yes. Yes. So the previous slide is fully extensible, right? So we talked about extensibility of this particular framework. It is fully extensible. right? It is fully extensible. Hold on. It is fully extensible. That means you can code and plug your own components into the whole mix, which is what people do.
Okay.
Okay. But more importantly, it has capabilities or code written for play with what do you call it, HDFS, edge space. So that's the advantage of Flume, is because it's got some target thing, but that doesn't stop you from writing sinks for that. So the first concept is the concept of an event. Events are basically anything you want it to be. The event has two parts. It's got a body, it's got a header. Body has the byte array payload, which means you can pass anything through that payload. You can pass images, you can pass textual data, you can pass JSON, XML, HTTP, FSEDIC data. You can pass anything you want. There's no restriction on that. So headers are specified as an unordered collection of string key value pairs with keys being unique across the collection. Okay, so header for an event is anything again you want it to be. Header can have any information which you want it to be, but the only thing is it's more like a map. It's a hash map where you have key value pairs corresponding to different things. Headers can be used for contextual routing. Actually, headers are mostly used for contextual routing. If the header says I'm an event of type this, I will be sent here versus here. So those kind of things can happen with events. So that's the first thing. That's the first concept in Flume, the concept of an event. Okay. The second concept is the client, right? The client is somebody who is generating events and sending them to one or more agents. Who are the agents here? Flume agents, the processes which are running Flume. Example is a Flume log4j appender, which essentially gets married into your Tomcat, JBoss, WebLogic, etc. servers, and is able to grab the logging entries from those files and streaming them through. Okay. Now, you can also write your own custom client using the client SDK, which is ORG Apache Flume API. So you can take ORG Apache Flume API and plug your own client. This client can be by the way, it's a Java program. Of course, when you are in the Java land, you can do JNI, right? So you can plug into anything essentially, right? Now, this client decouples from the system where event data is consumed from, right? Which is a very important thing. Is by virtue of these decouplings, you will have the client, the source, and all of those things. So client can produce data at a slower speed while the source can consume it at a faster speed and vice versa. Okay? So clients are not needed in all cases. They are not. I mean, client is something which goes, a Flume client is something which goes and embeds itself. It's a piece of code which gets embedded on the machine or on the infrastructure where your information is being produced at. Okay? So that's the concept of a client. So we have covered two concepts. What is an event? What is a client? The third core concept is agent. What is an agent? A container for hosting sources, channels, sinks, and other components that enable the transportation of events from one place to another. So an agent is something which allows you to take an event, perform some kind of processing on it, perform contextual routing, etc. on it. So this sources, channel sinks, and other components, we will cover that in a few, okay? These concepts will come back to you in a few. Agent is something which lets you do that, which is letting the sources, channel sinks, and other components to come together, right? Essentially, agent is that driver. Agent is a Java process which is hosting all of these sources, channel sinks, and other components, and it is the one which is orchestrating the whole flow end to end for a transformation or a routing of an event, right? Now, in an environment, there may be many agents. It's not entirely. It's not. You may have more than one agent which are contextually routing information amongst themselves for transformation and other things. Okay. Agents are configured by way of configuration files. They provide configuration, lifecycle management, and monitoring support for hosted components. Okay, so the hosted components, whether it's a source, a channel, a sink, or anything else, they provide monitoring support for hosted components. So we have covered three concepts: events, clients, and agents. The next concept is if you talk about an agent, this is how the things are laid out, right? So you have an application which is producing data, and the data is being produced at a pretty high velocity, right? Data is being produced at a pretty high velocity. So the data is being produced at 10,000 records per second. This is also producing 10,000 records per second, so on and so forth. So you're producing data at this thing, and this guy is feeding here, and this guy is feeding here. So these then become this becomes the collector agent tier. They can be called as collector agents tier, and this is the sink agent tier, meaning you're aggregating this whole bunch of events. Let's say I'm getting 50,000 events. You're aggregating them to this place. Okay? Does it make sense?
Yes. On the previous slide, you had the components of an agent as source, sink, and channel. So would the sources be these three agents on the next slide? If the one agent on the right hand side is the sink, what is source would be these three, or?
No, see, every agent. Let me explain this thing to you. Okay. Every agent, if I blow up this agent, right? This agent will have a source which is receiving data from this guy. Okay. It will pass. I'm blowing up this agent. Okay. What is inside this agent? That's what I'm doing. It will pass the information to a channel, and we'll come to a channel in a few. A channel may actually redirect the output to multiple sinks. Okay? And there may be a thing called interceptor sitting on top of here. So there may be an interceptor here. And there may be an interceptor here also. So an agent is anything you want it to be, but it's definitely a source, channel, and a sink. Okay? Does that make sense?
Yeah.
Now in this topology, this guy has a sink which is forwarding to another agent here. This guy's got a sink, it is forwarding to another agent here. This guy's got a sink, which is forwarding to another agent here. Does that make sense?
So in this case, the source will be the previous agent. Not, I mean, source in the sense, I mean the data where the data where that another agent would get is the previous agent.
Right. So the source is not the previous agent. I know you understood the thing. Source is not the previous agent, but source is the one which is receiving data from the previous agent. So the sink of the previous agent is redirecting data to the source of the next agent.
Gotcha.
Understood?
Yes.
Okay. Any questions?
So can we say agent has those components inside it? The source, sink, and the channel, and the interceptors.
Agent has those components inside it. Yes, it has.
Okay.
It has, right? So now next concept, what is a source? An active component that receives events from a specialized location or mechanism and places it on one or more channels. Okay? Source is something which receives events from anywhere. Now those events can come from a flat file. They can be sent to it by way of TCP, meaning it acts more like a web server. It can be listening for events on a specialized port. All of those things are possible. The source is an active component that receives events from a specialized location or mechanism and places it on one or more channels. Different types of sources are there, right? Specialized sources for integrating with well-known systems such as syslog, netcat, right? Auto-generating sources such as exec and SEQ. IPC sources for agent-to-agent communication, Avro. Okay? So there are many such types of sources, and we will go through them. We will use some of them for our purposes, right? Now, every source dumps its data into a channel. So by definition, every source requires at least one channel to function. If you don't have a channel, what is the conduit or pipe? And by the way, channel concept is coming next. What is the conduit or pipe through which data is going to be sent across or sent further? If you don't have that, then there's no concept or meaning of a source. If you don't have anything going further down, there's no meaning of this. So in that sense, the source always requires a channel. What is a channel? So what channel does is a passive component that buffers the incoming events until they are drained by the sinks. Okay? Different channels offer different levels of persistence, right? There is a channel. Okay, so before we start doing that, before we start talking about different channels offer different level of persistence, let me talk to you about why a channel is needed. Okay? So in my whole architecture, there are three concerns which I want to address. First is the concern of routing. That's the first concern. That I want to route based on some contextual value. For example, if this event came from California, send it to the Californian DMV. This event came from Georgia, so send it to the Georgian Department of Motor Vehicle. If this guy came from Texas, send it to the Texas Department of Motor Vehicle. So I'm doing some contextual routing based on the event coming through. Right? Number one. Number two, let us say for a second, I don't have this channel concept. I don't have this channel concept. So there is a source and there is a sink. Now, these sources and sinks, on one side is the target, which is consuming the data. On one side is the source, which is producing or capturing the data. Sorry, On one side, I've got the source, which is capturing the data. On the other side, I have the sink, which is consuming this data. Now, what happens if they are processing data at different rates? What happens in that case? That means one guy has to wait for each other, meaning one guy will be synchronized with each other. If the sink is slower than the source, then source would be blocked out by the sink until such time as sink has processed all the data. So there may be a denial of service in that sense, that the source may respond by saying, I can't pick up any more data because the sink is not able to run faster. So the second problem I have is that by decoupling the sources and the sinks, by putting a construct in between, I'm able to buffer events and therefore manage the speed between the source and the sink. Make sense? The third thing is, supposedly if there was no channel, that means sources are sending it to the sink. What happens to an in-flight event should the agent die? If the agent goes down for whatever reason, what happens to the source or the sink, to the whole flow? The answer is your event is lost. So you cannot have reliability, right? If you don't have a source and a sink, if you don't have a concept of a channel, you will not be able to have reliable delivery. So first is, if I have this as a source and this is the sink, SR, SI, and I have a channel in between, this guy can perform routing, he can ensure reliability, and he decouples the source from the sink and therefore allows them to operate at a different speed. It also allows you to plug and play, all of those things. Okay?
Okay.
So in that sense, there are three different types of channels. There's a memory channel, which is volatile, which means it's not going to give you it's not going to give you reliability. If something happens within the agent, you will have a problem at hand. Okay? Hold on 1 second, okay? Okay.
Yeah.
So the first type of channel is a memory channel. So it doesn't give you reliability. Moreover, if your memory channel buffers are overrun, it may end up blocking your source or your target or your sink. Okay. So that's the memory channel. Then the second thing comes up is the file channel. File channel. Okay. How many of you remember the write-ahead log file concept from HBase?
Yes. Basically, whenever we do a put operation, every put will write to the memory store as mem store, as well as it will write to the write-ahead log file on the HDFS.
Okay. Right. So write-ahead log file is a construct where you actually maintain a queue in a file. Okay. So you keep writing in an append mode to a file, new transactions, and you maintain in memory a checkpointed location of where in that file have you already read the data out from. So every time in the write-ahead log file is nothing that you have a file. And hold on 1 second, okay? Yeah. So then, sorry, I was explaining the concept of a file channel. Okay. The concept of a file write-ahead log file is, this is what happens in a write-ahead log file. Okay. The concept in a write-ahead log file is, what you will do is, you will keep writing transactions to a file. Let's say the file is growing in this direction. Okay. So you will say 1 some data XYZ. Then you're going to say 2 ABC. 3 4 5 in the memory of wherever you are at, you will maintain the location, the latest location which is there, and on the disk you will maintain something called a checkpoint file, and you say, from this file, the last transaction which has been read is the third transaction. You will maintain this. So because these operations in the raw write-ahead log file are sort of they pick up a batch of transactions. Every time you pick up a transaction and you say, well, it has been processed, that means I am committing to the write-ahead log file, you will update this pointer. You'll say 5 becomes 6 or 7 or 8 or 10. By virtue of doing that, by virtue of doing this, what happens is that you will never lose a transaction because it's persisted into the file. You have a checkpoint of what was the last time you checkpointed. Therefore, if there is a failure, you can recover from that last checkpointed location. Okay? But the concept on a Flume agent is a little different. The difference is it is backed by a write-ahead log file. In case of HBase, the write-ahead log file was on HDFS. In this case, write-ahead log file is on the local directory because you did not. I mean, you're not so much concerned about restartability across agents. You're not. So sky is the limit. If you wanted, you can put the write-ahead log file on HDFS also, but you don't do that typically. Next is the JDBC channel. Okay, go ahead.
Yeah, sorry. So you said this write-ahead log file is not on HDFS in this particular case.
Yeah, you don't need to put it on HDFS.
Okay, where does it go on?
Wherever you want it to go.
Oh, okay.
On the local file system, you can put it anywhere.
Okay.
Okay. Now, by the way, those channels are, the transactions in them are very short-lived. If your syncs are running pretty fast, then you would not see a transaction stay in there for more than a second. If your syncs are drastically slow, then yeah, file channels will start queuing up a lot of data. Lastly is the JDBC channel. It's almost like a file channel, but instead of a file, you have a database behind the scene guaranteeing the thing. Okay? Channels are fully transactional. What does this statement mean? This means that nothing is lost from the channel until you commit to the channel. And when you do commit to the channel, that means you have persisted that information to the next agent or the next target or to the target. Make sense? So until such time as you do not say commit, transactions are never lost. So it's fully transactional in that sense. You start a transaction, in that transaction you read a bunch of records, events, you do something with them. If there is a failure, you can pick up the same batch again from the channel. If there is a success and you commit to the channel, those transactions are then, those events are then marked as completed, and therefore in that sense it is transactional. Okay, so it provides weak ordering guarantee, which means that if an event came before another event, it will give you a weak ordering on it and will allow it to be coming out of the channel in the same order. Okay. A channel can work with any number of sinks and sources, which means multiple sources can feed into a channel and multiple sinks can take out of a channel. We will go over that concept in a few. Okay? Many sources can funnel the same data into one channel, and many sinks can take data out of the channel. Same channel. Okay? Next is the concept of a sink, an active component that removes events from a channel and transmits them to the next hop destination. That hop destination may be HDFS, it may be HBase, maybe an Oracle database, it may be the next agent, it may be anything. So that's why the next hop destination is important. Different types of sinks are there. There are terminal sinks that deposit events to their final destination, such as HDFS, HBase. Auto-consuming sinks, for example, null sink. So you just want the event to disappear. You're not interested in that event at all, then you will have a null sink, which is bam. It will consume the event went into a black hole, nobody cares about it. And you can actually forward it to the next agent by way of Avro. So there is an agent-to-agent IPC communication mechanism using Avro. Okay? Now, a sink cannot be tied to two different channels at a given point of time. A sink can only be associated with one channel. However, a channel can have multiple sinks.
Okay.
Okay? What this means is, this is my channel. This channel can do this. Sink 1, sink 2, sink 3, sink 4. It can do this. But you can't have this going on. You can't have this. Okay? This is not possible, this is possible. Okay? Okay? So what is the reliability flow? Reliability flow we keep talking about? You know, a sink, right? So it's kind of this is, so let us say that this is agent number 1 and this is agent number 2. Okay? Let's say this channel received events from somewhere. So sink will first start a transaction, it will take events and then end the transaction. Until this doesn't happen, none of the events get lost. When you say end transaction, that means you have committed these events to the next source, right? If these events are not committed to the next source, then you have a problem here. Events are never taken out of the channel. Once they arrive on this end, start transaction, put events, end transaction. Now if something happens here, guess what? This is going to give an error back to this guy, and because it gives an error to this guy, end transaction is never performed and the events are still there. So there is always reliability across agents. There is a reliability within agents.
Okay. Preetpal, I have a question.
Yes, sir.
So when we say transaction, okay, source can say start transaction. I mean, I did not understand in the left first agent 1, where the sink says start transaction and he starts taking events, and he says end transaction. That means the data is reliably, I mean, has reached the other source, right?
Mm-hmm.
So, and then, you know, for some reason, if the source also invokes a start transaction, That means, what does that mean? Does it mean that the data is completely, or it's in the next channel?
Concept is very simple. The concept is this. The concept is whenever you interact with a channel, you interact with the channel in a transaction boundary semantics. What does transaction boundary semantic means? It means that whether you're putting or getting data from the channel, it is almost like inserting and deleting. It's almost like that. You begin a transaction, and then when you're done with your insert or delete, you can close that transaction. What that means is the channel will always be in a consistent state. So you don't have, when you're inserting, let's say you inserted half of your event and then something happened. Guess what? Channel will not have that half event. It will rather not even have all the events which have been marked within a transaction. So the concept of transaction is allowing, in fact, in this situation, it's almost like a two-phase commit. That unless the source has not persisted its batch of transactions events into the channel, it does not commit itself to the previous guy, and therefore the previous guy is not going to remove those set of events from the previous channel.
Gotcha. Okay.
Okay?
Yeah.
So the concept of transaction is applicable both in the case of source writing to a channel and sync reading from the channel. So sources are hydrating the channel and syncs are dehydrating the channel. And both of them are doing within a transaction boundary.
Yeah, got it. Thanks.
Okay?
Mm-hmm.
Now, of course, I also talked about the fact that a given channel, can forward to multiple agents, can forward to multiple syncs, or it can choose one of the syncs to forward based on some contextual information. So in that sense, there is built-in load balancing support and failover support available in this whole construct. And it is available in this fashion. Okay? So in a normal sense, a source is writing, in a normal sense, a source is writing into a channel and the sync is taking out of the channel and putting it here, and it is going here, right?
Mm-hmm.
But if there is an error, right, let's say here, right, something is broken. Guess what? This channel already has the transaction, this set of transactions are never lost here. So what I just discussed with you is possible. When this channel comes back up again, when this agent comes back up again, then you can start forwarding it to it again. Make sense?
Yes. So till then, he will wait for that agent to come up.
It depends on the configuration you defined.
Okay.
It can take the set of transactions and forward it to a different guy altogether.
Okay.
Okay? Flow handling. So channels decouple impedance with upstream and downstream. That's what I was explaining. If one guy is doing 90 miles per hour, other is doing 30. Channel kind of, let them operate in 90 and 30 miles per hour mode until such time as the channel fills up. So upstream burstiness is damped by channel. Downstream failures are transparently absorbed by channels. Sizing of channel capacity is key in realizing these benefits. So if you have too big of a channel, then you have some problems. If you have too small of a channel, then you have other problems. That's what flow handling, all of this means. Okay? So we have kind of covered all the basic concepts. Now you know what an event is. You also know what a source is. You know what a sink is. You know what a channel is. You know what a client is. You also know how the reliability and other things are achieved. Okay? Any questions? Okay. So how do you configure a channel? How do you? In a slide previously, I talked about the fact that agents are dynamically configured by way of configuration files. So how do you configure an agent? This is how you configure an agent. Okay. The namespace in a configuration file is hierarchical. Okay. What that means is if I provide any configuration information, it is hierarchical, meaning, man, on this Mac, somehow, this pointer, the pen, has to be reset every time you go to the next page. Okay? So hierarchical means that you have the agent name here. The component involved within that agent, it is channel. So if this was not a channel, it was a source, you would say source. If this was not a source, it was a sink, it is a sink. This is the name of that channel, right? And these are the descriptive fields of that channel. What is the type? It's a file. How much capacity will it have? 1,000. How many max what is the transaction count it will give to the guys? X something, X, Y, Z. So all of these things, they are hierarchical, meaning you have the agent.channel.name. Then you have agent.source.name. Then you have agent.sink.name, right? Then this channel, agent one.channel.name.type. Similarly, you have sink.name.type. So it's hierarchical in that sense. Make sense?
Yeah.
Okay. So now, how is the source tied to its channel? This is how you tie it. So you say, I've got the source, the name of my source, the channel is my channel. So my channel's information is here. Okay?
Okay.
Similarly, you will have agent1.sync.mysync.channel. Now, keep in mind, this is channel, not channel, is equal to my channel.
Okay.
Make sense? Now, I can also have channels, my channel 1. Then you define sources, the set of sources, you define the set of sinks, then you define the set of channels. And then you say the definition for each of these sources, right, is here. By the way, you have to define my source 3. You can't use my source 3 until you have defined it here. Like custom components get their own namespace, meaning type is this atom source. So if you write your own source, you can write the whole thing like this. If you use some of the built-in sources such as Avro, HTTP, so on and so forth, you will do it in this way. So basically, this Avro maps to this particular thing. And then within this atom source, if you're passing certain parameters back, again it's hierarchical. Cache duration, feed. These are parameters being passed to your this thing. So you can essentially write anything you want to write. Okay. So this is a sample configuration file for a agent. So you have agent 1 source src1, channel ch1, sink is sync1. So you say src1 type netcat, channel is which it will publish to ch1, bind port is this, port is this. This is because it's netcat. It needs the source and the IP and the port for doing netcat. And then the sink is a logger sink. It's tied to ch1, and the channel definition is this. So by doing this, you have changed the source to the sink by way of the channel. Because by mentioning the channel name here, you are able to cat it. Okay?
So when we say sync type logger, what does that? I mean, just curious.
It will basically take that event and log it to a file.
Okay.
Okay. There are some built-in types of sources, and we will go through that in a few. Okay. Configuration. A configuration file can contain configuration information for many agents. So the same file can have information for many agents. Just keep in mind that there is this agent 1. So if the agent is agent 1, if the agent who's running is proclaiming to be agent 1, then only he will read only his set of configuration entries, and he will not read the configuration entries for the other guy. Okay? So in such a way, one configuration file can contain configuration information for many agents. Only the portion of configuration associated with the name of the agent will be loaded by that agent. Components defined in the configuration but not in the active list will be ignored. Right? Which means if you don't have, the naming is hierarchical. So if I have information defined for agent 2 and agent 1 is reading that configuration file, it will disregard whatever is there for agent 2. Components that are misconfigured will be ignored. Agents automatically reload configuration file if it changes on disk. Okay?
Okay.
All agents in a specific tier could be given the same name. One configuration file with entries for 3 agents can be used throughout. Okay? So the same configuration file can be used for all agents. Is that okay?
Okay.
So how does contextual routing happen within a Flume flow? The way it happens is by this concept of what they call as interceptors and channel selectors. Okay, so basically through this concept of interceptors and channel selectors, you can do contextual routing of events. So interceptor is basically something which you introduce between the source and the channel, and this guy's job, interceptor's job, is to manipulate the header of that event. It can also drop that event completely. So it can drop that event completely. Or it can also take one event and make 10 or more events or 50 events or 100 events out of it. Make sense?
Okay.
And you can make the interceptor also take 50 events, but it's a little complicated. You can make an interceptor take 50 events and make it into one event, but it's a little tricky. Then there is this channel selector. Channel selector is not something you code. You do code an interceptor if you want to. You do write a code for interceptor. A channel selector is something you often do, you never code. There are two kinds of channel selections. One is multiplexing, other is replicating. So based on a certain attribute in the header, you can multiplex or replicate or multiplex, replicate or multiplex a given event to go to one or more channels. Okay, you can make a event flow to one or more channels by use of this concept. Okay. So contextual routing, interceptors. An interceptor is a component applied to a source in pre-specified order to enable decorating and filtering of events where necessary. Built-in interceptors allow adding headers such as timestamp, hostname, static markers, etc. Custom interceptors can introspect event payload to create specific headers where necessary. Essentially, you're playing with the header or dropping an event. That's what interceptors do. You can play with the event by doing some logic and then putting a value in the header which can assist in downstream processing or routing of the information. You can completely drop the whole event. So an interceptor can do all of those things for you. Okay. Channel selector allows the source to select one or more channels from all the channels that the source is configured with based on preset criteria. There are two types of channel selectors, replicating and multiplexing. For duplicating the event, so you can take the same event and push it off to 5 different channels. Multiplexing for routing based on headers. So you can route an event, just like I explained a few minutes back, that a California event should go to California DMV. A Texas event can go to Texas DMV. By the way, you can have a replication within multiplexing also. So you can replicate an event after it has been multiplexed. That's also possible. So how do you configure this kind of a thing? How do you configure the channel selector thing? The way you configure it is this, right? So in the header, in the event header, there is a field called priority. If the value of field priority is high, then you will send it to channel 1. If the value is low, then you send it to channel 2. If it is anything other than high or low, you send it to channel 2. That's how you can route events. Make sense?
Okay.
Isn't that cool? So you can explode events. Now if I say replicating, instead of typing multiplexing and I say replicating, I don't need header. I don't need the header value. I just replicate. Now if I wanted to replicate the event, if I wanted to replicate the high event to 4 channels, I will say CH3, CH4, CH5. If I CH6, CH7, CH8. I can do that. So now anything with a high value is going to be replicated to all these channels.
Okay. So just I have to add the channel names there. That will take care.
Yeah.
Praveen.
Yeah, Praveen.
Yeah. One question. So this selector dot mapping dot high, right? So this mapping is the header. I mean, what do you say? Kind of a variable or a value?
No. Mapping is a keyword. Mapping is essentially saying this value for this guy, this value for this guy. Mapping is a keyword really. Understood?
No, not yet actually. I mean, I got that mapping is a keyword, but how does it refer? I mean, what is it?
Okay, so let me explain that. Okay, so let's say there is a source, right? Let's take the example. Here is a source. This is an Avro source, meaning it is receiving data from somewhere. So event by event, you pass it to an interceptor, right? Let's say this is financial data, right? You want to have some kind of manual processing on high values and some kind of automated processing on low values. You are saying in the interceptor, you are saying if event dot, XYZ dot amount is greater than 0, then you're going to create event dot header dot priority is equal to low, is equal to high. Let's say I'll put a bigger number. I'll say $1,000 high. Else you will put a event dot header dot priority is equal to low. So now your event is being sent to a channel. This channel, right? Actually, no, event is not being sent to a channel. Event needs to be sent to a channel. Now, in the header of this particular event, this interceptor has put a value for the field called priority, and the value is high. So, if the framework realizes that the field is priority and its value is high, then it will forward it to channel number CH1. If it is low, it will forward it to channel number CH2. Now, associated to this are its own sinks, S1 and S2. And they will manipulate or manage their corresponding thing themselves. Okay? Make sense?
Okay. Yeah, good. Thanks.
Okay. So high and low are values for priority. High and low are values for this priority. Okay? It's your job to put something in the header called priority and assign appropriate value. If appropriate value is not assigned, where will all the events go?
Into
Huh?
the default channel, right? Or I mean, at least in this one.
Yeah, so they'll go into default channel. Okay? Contextual routing. Again, terminal sinks can directly use headers to make destination selections. HDFS sync can use header values to create dynamic paths for files that the event will be added to. So what this really means is let's say I have a HDFS sync, meaning that sync is writing to HDFS. It can use information made available in the header to find out which file this particular event needs to be written to. Or it can also use this thing, to say, okay, what directory I need to store the information under. So the event header can be used by the sync to do whatever it is. Now, keep in mind, what Flume is a part coding framework. It is partially a coding framework, meaning you can write your own things, you can write your own sources, you can write your own interceptors. You typically don't write channels. You don't. And then plug those custom components into your this thing. Or you can utilize some of the pre-existing coded sinks of channels, sources or sinks and interceptors to just say, okay, I think in my project I can use this particular HDFS sink, which is already provided to you. So then you have to just read up the documentation for that sink to say how am I going to plug it into my framework pretty quickly and how can I use it. Okay. Now, Flume is very configurable. You can plug and play a lot of things into the whole architecture and it works very seamlessly. In a given project, you can quickly wire up things by just writing two classes. One is your interceptor and another is probably a serializer if the type of data to be persisted is not going to a totally different type of sink. Okay, so it's that flexible. It is that flexible. So there is another thing, you will notice about this Flume when it is writing to something like an HDFS sink. It does one thing which is very important for sinks, for HDFS. Remember when we were doing HDFS, I talked about the problem of small files?
Yes.
All right. So who's awake? Just Praveen? Pramod?
Pramod.
Anna is sleeping. Anna, can I get you a cup of coffee?
No, I'm here. I'm listening.
Okay, thank
Not
you.
very clear. I just would like to ask you one thing.
Yeah, go ahead.
Yeah, I'm trying to actually get those, the training session which you are recording just to get for the second time so that my concept will be more clear. But I don't know, where did you upload them? So if you can send me the link.
I haven't uploaded it. I have today, as of right now, been successfully copied over the set of recordings. So I'm starting to convert those. I will put the conversion up probably by tomorrow. You should. I'll have those conversions and then I'll upload them on YouTube and give you the access. Only you guys the access.
Right. But the thing is, will that be everything up until now, or will that be some of the things?
No, I think it will be everything up until now. Okay.
Okay. Yeah, because if I go second time, then this concept will be more clear because it's a lot of things. It is a very super, superficial way it is coming to me right now. So.
Okay, that's fine. The recordings you can go here back and like you said, yes. So anyway, the question at hand is, if you notice what is happening in case of Flume, in case of HDFS sync, is by virtue of having something like Flume feeding into HDFS, you can solve the problem of small files. Does that make sense?
But how would that happen? Yes, that would solve, but
okay, I'm going there.
Okay.
But first of all, other than Pramod, can anybody articulate what is the problem of small files in HDFS?
Yeah. So Praveen.
Yeah.
So typically the master node, right? It keeps all the metadata or information of all the files stored in HDFS in memory. So if you have, millions of files, small files, so the total number of information it has to store in memory will increase. And the other issue I think is also, that is I think the main information.
Yeah, there will be on the HDFS itself, there will be very small blocks. So let's say you define a block size of 128 MB, but you are creating a file of 1 kilobyte. So there will be a block of size 1 kilobyte. You cannot pack multiple files into one block, by the way. unless you do something else, which we are doing. So there will be this small 1 kilobyte blocks. The cost of accessing these 1 kilobyte blocks over the network is constant. Whether you do 1 kilobyte or you do 128 MB, the network cost of seeking that block is the same. So therefore, if you have a really small block size 1 kilobytes, the amount you spend doing the network thing is more, because in case of 128 MB, you're going to do it for a millisecond and you will then be reading it for a second. In this case, you will be doing the network seek for a millisecond and you will be reading the data for a millisecond. So the cost of doing the network seek is almost equivalent to the amount of time you spend to read the data. So that is the problem of HDFS. Bigger problem is within the name node when you have small files. Bigger problem is within the name node when you have the small files. It creates a bigger footprint of files and data blocks than what is required. So how does Flume solve it? The HDFS sync can take those events, and by the way, when you go to Google and by the way, I'll do that. Let's go to Google. Let's share this page. Okay. So I'm here on Google, okay? So if I say HDFS sync Flume, okay, and I go here, HDFS. Okay, so here is an HDFS sync. So here are the different parameters by which you can configure an HDFS sync right here. Okay. So what this is telling you is, you're saying roll interval is 30 seconds. Roll size is 1024 bytes. Roll count is 10. Batch size, we don't care. So between these three, if let's say you're streaming a lot of small files, if you have 1 million small files, by these three parameters, roll interval, roll size, and roll count, you can say, do not create a new HDFS file. You can tell the sync, do not create a new HDFS file until 30 seconds have passed by, which means the amount of data you would have processed in 30 seconds would probably be more than one small file. It would at least have thousands of small files in it. So in 30 seconds, you may be generating data worth 10,000 small files. So in this way, you're able to take 10,000 small files and convert it into bigger block sizes, which name node HDFS likes. The second thing is roll size. That okay, it's not yet been 30 seconds. 30 seconds have not yet expired, but the file size has hit a certain size. Then you can say, okay, cut me another file. So this way you can have a more fixed size files for processing. And then roll count is, okay, the file size has not achieved this level and the time has still not expired, but I have written 1 million events to the file. Okay, well then let's cut a new file. So these are the ways by which you can solve some of the other problems related to HDFS. Does this make sense?
Yeah.
Okay. And again, many such things can be done on an HDFS thing. If you see this right here, you can take the host name, the Unix time in milliseconds, etc., 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 etc. So you can do all of these things on the file. for example, HDFS file is event percentage Y, percentage M, percentage D, percentage H, M, percentage S. So what is percentage this right here? Okay. That's what you can do. Custom channel selectors can be used for doing specialized routing where necessary. Now, pretty much those two concepts are good. But if you wanted to do more, you can write your own channel selector. It's not a problem. Load balancing and failover. So how does the load balancing and failover happen in Flume configurations? There's a sync processor. A sync processor is responsible for invoking one sync from an assigned group of syncs. So now, instead of a channel writing it to a sync, you will write it to a sync processor. And the sync processor will manage a group of syncs. So think of sync processor as a sync, but it has multiple syncs within it. A sync processor is responsible for invoking one sync from an assigned group of syncs. Built-in sync processor, there's a load balancing sync processor which is using random round robin or custom selection algorithm, failover sync processor, and default sync processors. Okay. So essentially what I'm doing is I'm changing the concept of a sync a little bit. I am introducing a concept of a sync processor, which means that if I have sync, so what am I trying to do? I'm trying to do high availability. If I have sync S1, S2, S3, S0, and a channel is writing to these guys, what I'm doing is I'm introducing a concept of a sync processor where the channel writes to the sync processor, and sync processor can select one of these syncs or all of these syncs, or always this but not this, this and this. It can use any of those policies to select a particular sync to forward that transaction into. Whatever reason this sync goes down, the other three are available and the event will be sent to the other three. So by this topology, I'm achieving failover and load balancing. So I can do random, which is I can pick one of these for every event coming through, or I can do round robin, which is I can circle in the syncs in this fashion, or I can have a failover sync, which means I will always send it to this sync, but if this sync goes down, then I'll start sending it to this. If this goes down, then I'll start sending it to this. If this goes down, I'll start sending it to this. So these are the various topologies which are available for syncs. And there is this concept of sync processor, which is sort of a higher concept. Okay.
Okay.
So sync processor invoked by a sync runner acts as a proxy for a sync. So it's basically a proxy which you put in front of a sync. So that's what a sync processor is. Okay. Sync processor configuration applied via sync groups. So you can actually start doing sync processors in this way. You can define a sync group like this, FO group. In FO group, you have sync 162. Type is its failover. Priority sync 1 is 5, sync 3 is 10, max penalty is 10,000. Right? Do not ask me what max penalty means, but you can quickly go into the documentation and look at this, right? So I can quickly go to this and say, by the way, this is your best friend, Flume user guide. Once you understand the concept, you can always spend a lot of time here doing all of this. Max penalty, 30 seconds. For the upper level to failover time can be set using max penalty. So yeah, you can read this documentation to see what it is doing. Okay.
Yeah. Question. From the sync processor concept, it appears that the data is always pushed to the sync. Is there another sync to pull the event from the channel, or it's always data?
It's not. It doesn't work like that. The data is not pushed to the sync. There is this concept of what they call it as a sync runner. Okay. This sync runner's job is to watch the channel. Okay. Its job is to watch the channel. If new data arrives in the channel, then it instantiates a sync, and sync takes the data from the channel, not really pull the data from the channel. Make sense?
Okay. Yeah. So
sync runner is the guy who's managing all the sync within the framework. Okay?
Okay. And there was other concept you introduced on the previous slide, channel selector, writing a custom channel selector. How does it contrast between what we have seen earlier, the configuration file you can specify which channel it has to go to? You have an option to specify based on file.
You were breaking and your sound quality is not good.
Okay, there's two ways I'm seeing this channel selection. So the one we are looking at right now is through configuration. You can select the channel based on a field, header field. So that's through the configuration file. In the subsequent slide, we also saw the ability to write a channel selector class. So I was trying to understand what would be the contrast or difference between these two mechanisms.
Okay, so channel selector will forward it to a channel. So channel selector is more of a channel concept. Okay. Sync processor is a sync concept. So channel selector does not need to worry about availability, failover, all of those things. None of that. So channel selector does not need to worry about that. Channel selector is merely saying, okay, this event needs to be sent to what all channels, not which all channels, but what all channels. It may be one channel, it may be more than one channel. Sync processor is not concerned about that. Sync processor is, okay, I've just received an event, which sync should actually process this event. Now that sync which processes this event can be based on failover policy, it can be based on a load balancing policy, any of these, failover or load balancing. So it will select the available, quote unquote, available sync based on those two policies, right? So channel selector is merely responsible for publishing an event into a channel, which the source is doing. What channel it is, that's the job of channel selector. But sync processor is which sync should be taking the event out of the channel, which sync should be taking out the event from the channel, and it's doing that by that way. A sync can exist in at most one group. A sync that is not in any group is handled via default sync processor, which means by default, if you do not specify a sync processor configuration, a sync is in its own default sync processor group. Okay? So default sync processor group allow, it basically every sync by itself is in its own default sync processor group. Okay? Removing a sync group does not make the syncs inactive, right? So that essentially, I think I've we've covered a lot of ground today. So in a summary, clients send events to agents. Agents host number of Flume components, sources, interceptors, channels, selectors, channels, sync processors, and sinks. Sources and sinks are active components, whereas channels are passive. Sources accept events, passes them through interceptors, and if not filtered, puts them on channel, selected by the configured channel selector. Sync processor identifies a sync to invoke that can take events from a channel and sends it to the next hop destination. Channel operations are transactional to guarantee one-hop delivery semantics. Channel persistence allows for ensuring end-to-end reliability. Any questions on this, guys? So we have introduced a few concepts: sources, interceptors, channel selectors, channels, sync processors, and sinks. Any questions at this point of time about any of these concepts? We have understood how routing happens. We have understood how contextual stuff happens. We have learned all of those things. Okay.
Are interceptors only on the source end of the channel, or will they be also be introduced on the sync end of the channel?
It is definitely on the source side, but I think you can write interceptors on the sync side also. Okay. What has not been introduced into the whole mix is that just like interceptors is a concept on this side, there is a concept of serializers on the sync side. Okay. So if you wanted to transform your event or do something with it or set it up in a certain way before you persist it into the next hop, you would use a serializer. And when we go through the code, we will look at that aspect. So what I will do is, I don't want to overload information today into you. So what I will rather do in this case is we will take a slight detour and we will look at, we will look at some of the code stuff required to create something for Flume. By the way, you can get a by not writing a single line of code and just using these configurations to take a data from a flat file into HDFS or HBase. You can actually get by doing that. But sometimes you do have to write code, and it's okay. It's okay to write code. Okay? So next, after when we meet next time, we will do Flume sources. Okay? We will talk about a little more about Flume sources and how Flume sources work and all that. We'll talk about different types of Flume sources, how does the transaction policy gets applied, and all of those things, right? But let's take a detour now and the moment I touch this right here, it puts me on mute. The moment I touch this right here, it puts me on mute. Eclipse. Okay. By the way, you can, because this is all open source, you can go here. You can say GitHub, Flume-ng. You can go here and you can download the whole code. This is your whole code. So you can do a copy of the Flume code from here, right? So there are channels, there is the code for channel, right? There is clients, there is configuration, code, distribution, there are documents, there are legacy sources, Node, ng SDK, and Flume-ng syncs. You can do any of that, right? If you look at the latest one here, right? So you can download this whole thing from there. I have downloaded this. So these are different projects. Actually, open the project, right? So I've downloaded here the project. So there are this channel implementations, abstract channel, channel processor, channel selector factory, default channel factory, memory channel, replicating channel selector. So this is the way, these codes are written. And you can browse through the code and look at the code to see what this code is doing, okay? Typically, when you write a project for this, if you go here, let me give you an example of what the things look like. So if I go here, and I go to Flume, I can look at the configuration, right? Agent, I can see agent. Actually, I can do this. This is a configuration file for Flume. So you have tier source, netcat1, transaction channel capacity is 100. If it exceeds this capacity, it will block this guy. So those are the sort of things which you do. I have Flume leapage. I have 3 agents here. If I go here, actually if I go Flume and I've got 7, let's go here and look at this guy's configuration. This guy's configuration has got tier 1 sources ATC log. You have sinks. These are your sinks. You have 1, 2, 3, 4, 5, 6 things. You have these many number of channels, 1, 2, 3, 4 channels. Sink groups, right? I have defined a group called group 1. Within group 1 is this, sink 2, sink 1, sink 3, and I'm doing a load balancing scheme, which means all the transactions within the sink group will be sent to 1, 2, 3 in that order. Then the source is folder, which is basically tailing the files from here, creating events out of them, and passing it along. And then you can write your own deserializer for reading from this folder and doing something with it, right? Then you have Avro channel type file, which is what type of channel do I want to have, transaction capacities. This many transactions can be put into the channel until it blocks. Checkpoint interval is 300,000. So after 300,000, I mean, whenever there is a checkpoint, 300,000 transactions are taken out of the channel. Max file size for this particular channel is this big. Capacity of this channel is how much? 100 million possibly. No, it's 10 million. Checkpointer, where do you keep the checkpointed data here? Where is the data there? You keep it here. So these are individual channel definitions. 1, 2, 3, 4. 4 channel definitions. Then you have a sink. The sink is an Avro sink. It's associated to this channel, and it is going to forward its events to this particular server, and that will forward it on this port. It will forward it on this port. By the way, because I may be doing, so I've got an HDFS sink which is writing to this location, ATC log. Log roll interval is 600, which means about 10 minutes, I believe, right? Roll size 0, never roll based on file size, never roll based on number of events. So it's basically purely based on time. So if create a new file every 10 minutes, right? Assuming that enough events will be generated in 10 minutes. Number of events written to file before it's flushed to HDFS, this many, batch sizes, 100,000. So bigger the batch size, the faster the thing goes, but bigger the batch size, you require more resources for that. File type is data stream, call out, thread pools, file size, etc., etc. I've got HBase sync file type, which is using this class as the sync, right? By the way, this is coming from out of box from the Flume framework. So I'm using this, and you can write it to a column family. You can say what is the table name in HBase where you need to write, what's the batch size. I'm writing a custom serializer, which is my own serializer, to write it to a certain place. Do some transformations on the events which are going to be persisted into HBase. Similarly, async HBase, HBase. Finally, there is this section which is multiplexing. I'm multiplexing based on agent num. If the channels which are participating in this multiplexing scheme is channel 1, channel 2, this thing. So the same ATC log source has got these channels associated to it. Okay? And then if the value of agent number is 1, you send it to these 2 channels. If it is 2, send it to these 2 channels, etc. If it is default, send it to these 2 channels. And then I have the corresponding syncs associated to the channel. That's it. So this is a sample file which looks like this. So you can go into Cloudera Manager, look at individual agents. You can go to 7. You can look at the full STD out and see what's going on. Yeah, okay. So these are some of the errors which are happening. Well, all these agents are still running, so that's what it is. So yeah, we'll take a hard stop here. Is that okay?
Yeah.
Is that fine?
Yes.
Okay.
Yes.
Sure.
Pripal, I have one question. It's like, in a real-time scenario, where does this Flume agents would sit? I mean, right now, what understanding I have is like they are writing to HDFS, so not necessarily HDFS, but just assuming they are coming, we are bringing the data into the Hadoop ecosystem. So where would this Flume agent sit? Are they sitting in the Hadoop environment, or they are outside where, let's say I have web servers, outside the Hadoop environment?
The answer is both. The answer
both.
is both. Answer is it depends on you.
Okay. So if I have to have it on the web server side listening to the weblogs, so I would be configuring those Flume agents.
Right. So you are the guy who does the